Everyone, this is the 2P online tutorial class, and today I'm more interested in discussing one of the problems in further mathematics which we are all familiar with. And this topic that I'm interested in discussing today has to do with conic section. In one of my videos, I have discussed the conic sections as regards the circle. That is, these conic sections is divided into 4 groups. Number 1, we have discussed it with the circle. That's the first one. Number 2, with parabola. Number 3, we have also discussed it. I want to discuss it as regards to ellipse. And number 4, I also want to discuss it with regards to hyperbola. All of these concepts is what I intend to discuss this particular topic with. Now, discussing the circle, I have already made a video on the circle where I discuss the equation. Let's just come a little bit of revision as regards to this, where I discuss the. Let's just look at the circle quickly. Just a very short class on that, a short revision on that, where I discuss the circle as regards the equation of the circle and as regards the tangent and the normal to that same circle. I also said that for you to have the equation of a circle, there are 2 major points you need to always remember, which are the center of the center and the radius of the circle needs to be known. For you cannot find the equation of a circle without knowing the center and the radius. And by so doing, we have a situation whereby we have a circle being defined, we have a center, and at this center we have this point, which is your point P of x, y. This is the radius and this is the center. So this center, now we have 2 cases. We have a situation whereby the center can be placed at the origin. We can also have a situation whereby it is not being placed at the origin. If it is being placed at the origin, we have it to be 0, 0. But if it is not placed at the origin, we are going to call that point A, B. And with that, I was able to show that this radius, which is r square, is equals to the distance, which is what now, x minus a all square plus y minus b all square. It is this particular equation that is being expanded to x square minus 2ax plus x square plus y square minus 2by plus b square equals to r square. Now, resolving this particular problem, if I to resolve this particular by arranging them in their order, we are going to have here as our x square plus y square minus 2ax minus 2by plus x square plus b square minus r square equals to 0. This equation is what we refer to as the general equation, though we have been able to reduce it to be more of positive, thereby recalling this one as, if I make this a, which is this a, as my minus g, and I make this one as my minus f, and I summarize the whole of a square plus b square as minus r square to be c, then this equation will reduce to something related to x square plus y square plus 2gx plus 2fy plus c to be equal to 0. And this is exactly what we have been using to solve the circle. This formula here explains the general equation to a circle. Now, today, the interest is not on the circle. The interest is on parabola. And there are major key terms you need to understand when it comes to this aspect of parabola. And when we talk about this parabola, what are the key terms we need to? We'll be hearing words like the latus rectum, you'll be hearing words like the focus point, you'll be hearing words like the vertex, you'll be hearing words like the directrix. All of these words that you are going to be hearing, these are the words that I will be using personally to explain this particular concept. So I just mentioned, I said we are going to be considering the parabola. This is what we are going to be considering today. So first, when we talk about this parabola, what is this parabola about? we talk about the parabola to be the what? The locus of a point which moves such that its distance from the focus is equal to the distance in the directrix. I want to say that again. I want to say that the parabola itself, the parabola is the locus of a point. The locus of a point which moves such that its distance, such that the distance from the focus is equal to the distance from the directrix. We are going to explain each of these concepts briefly. Now, when we talk about the parabola can come in different ways. We have a parabola that can be like this. This is the one part of the parabola. We can have it out in another way when it is being placed like this. When it is being placed like this, we have it being placed in the opposite way. We have it like this. We have it this way. You can also have another part of a parabola that explains this, that is being placed like this. We also have the last part, which is the fourth case, a parabola that is being placed like what? Like this. Now, each of these parabolas have its own equation. Each of them have its own equation. So now, if you look at what I explained briefly, I explained that the parabola is the locus of a point which moves such that its distance from the focus. Now, this focus can be placed at any point. Either you place it on the x-axis or you place it on the y-axis. So, placing a point here, this is where I refer to as my focus. And my focus at this point means it's going to have a value which is going to be a, 0. If I place it in the other part of this is the other part of this now. So I am having my f to be, I would like to picture these diagrams clearly on the other part of the board. So now, if we place it on the other side here, it simply means that my parabola at this point, by placing this in the other side like this, simply means that this is the focus here. If I place my focus here, my f here will be minus a, 0. That is the value of f. F is minus a, 0. Now, this same focus I have here, I can also have it being placed in this other way around, placing it by allowing it pass through the origin. And if this should pass through the origin, I will have my focus being placed at the what? On the y-axis. Look at the two differences. You can see that this one is facing this direction, that is to the negative x, while this one is facing this direction to the positive x. All of these are actually passing through the origin. Now, looking at this now, this one is also a parabola, is also facing to the positive y. And on the positive y, the focus now will be f, will be equals to a, no, it will be f is equals to 0, b. Why did I say f is equals to 0, b? Why are we using this here? Y is the only one that has a value here. Y has a value here. The x does not have a value. Now, the same thing is also applicable when we have it being placed in this manner too. We have it being placed here. We have a situation whereby this is now being placed like this, being placed this way. And when it is being placed this way, we are saying that our focus at this point, our f at this point, will then be 0, minus b. Now, remember what I said earlier. I said, for this class, we need some key things apart from the definition of what a parabola is. So now, one of the key things I said, number one, we need to understand what a focus is. Number 2, we need to understand what a directrix is. Number 3, we need to understand what a vertex is. We also need to understand what a lactus rectum, also discuss. We have the focus, we have the directrix, we have the vertex, we also have the lactus rectum. Alright, so like I said before, I said, for you to understand the concept of parabola, then these 4 things, the focus, the directrix, the vertex, and the lactus rectums, you're supposed to understand them into details. Now, consider the focus. I said the focus are special points. I said the focus are special points with reference to which any variety of a curve is being constructed. What do we mean by that? It simply means that I can place the focus on this particular line. This can be a focus. It's just a reference point. It's a reference point. If you remember when we defined the parabola, we said a parabola is a locus of a point, and that point now is what we refer to as the focus. And that is what we refer to as the focus. So, and that focus now is the one moving. It can move like this to the x, positive x. It can move to the negative x. It can move to the positive y. It can also move to the what now? To negative y. Now, that focus now, it can be for this particular parabola. At this point, we can call it definitely is going to have a value here, which is going to be a, 0. Now, to have understood this simply means that if you are now asked that what is now a directrix is a parabola whose line is perpendicular to the axis of the parabola, which does not touch the parabola. I will say that again. I said the directrix of a parabola is a line that is perpendicular to the axis of the parabola, which does not touch the parabola. Now, by all indication, I would like to show you this. If this particular, we are placing this directrix here, so I'm going to call this directrix. Let's label this place as our, let's call this place A. Let's call this place our what? Our B. So this line AB is the directrix, and this particular line is actually perpendicular to the axis of symmetry, and this axis of symmetry divides this particular curve, or we can say bisects it into 2 identical parts. Now, this is a clear indication that we can have this directrix. It can come either as minimum, it can come as what? As maximum. Minimum in what sense? We can have the axis of symmetry being placed in this format. We can have it being placed in this format, be it as minimum point. We can have it this way, which is what? We have it as this point. We can also have it as this point. This is the minimum. Why this one is the what? Is the maximum. So we are having this as the axis of symmetry. This is the axis of symmetry. And the axis of symmetry, in our own case here, this is the axis of symmetry, is dividing this curve into 2 identical parts. Now, knowing fully well that from my definition of what a parabola is, I clearly stated out that a parabola is a locus of a point which moves such that its distance from the locus from the focus is equal to the distance from the directrix. Now, meaning that this focus point here, we're saying that the distance here, if here is a, is equal, here is just what now, minus a. So tracing this up here, I can as well have this particular point here to be tagged. This is just this line here. We are saying that we have it this way. If I label this space as p of x comma y, definitely at this point here, this my, let me call this point m. My point m here will be minus a comma y, because this has a value of y at this point. This space has a value of y. So I say minus a comma y. So if here is a, then the directrix here is x to be equal to minus a. Please let's take note of something, that this vertex now is at the origin 0, 0. The vertex is not all question that you have the vertex to be placed at the origin. It's not all questions that you have the vertex to be placed at the origin. In some questions, you can have the vertex to be placed away from the origin. You can have it being placed here. You can have it to be being placed like this. It is not a must that the vertex must always come from the origin. Now, with what I've said and for my explanation as regards to this, now let's see what is the equation. We want to see the different forms of the equations of this particular parabola. Now, the parabola can come in different ways, one of which is y squared to be equals to 4ax. That is one of the ways a parabola can come. Another way a parabola can come can be y squared to be equals to minus 4ax. Another way a parabola can come, you can have a parabola to come in this format of x squared to be equals to 4ay. We can also have a parabola to also come in what format again, as x squared to be equals to minus 4ay. These are the format by which a particular parabola can come. So when a question is given, you need to identify what form is the parabola itself. Is it the form of y squared is equals to 4ax? Is it the form of y squared is equals to minus 4ax? Is it the form of x squared is equals to 4ay? Is it the form of x squared is equals to minus 4ay? Now let's see how this particular parabola is being formed. Remember what we said, that a parabola is the locus of a point which moves such that its distance from the locus, from the focus, is equal to the distance from the directrix. Quickly, let's look at this. So that means we are saying that the distance from here is equal to the distance here. This is the distance of the focus. This is the distance of the directrix. We say they are equal. So in that case, we are saying that your PM, square is equals to PF all square. And by so doing, we are saying that our x minus a, that's x minus a, that's x plus a all square, plus y minus y, that's 0, so we don't need to write that. So y minus y, that's 0, equals to, that's the distance now, PM square. The distance of the directrix now equals to the distance of the focus, and that will give us x minus a all square plus y minus 0 all square. Looking at this particular question carefully, you will observe that if I expand this carefully, we are going to have x square plus 2ax plus x square is equals to x square minus 2ax plus x square plus y square. Now, if I cancel this x square, I cancel this x square. If I remove that x square and I remove the other x square, and I also remove this a square, I remove this a square, I'll be left with 2ax to be equals to minus 2ax plus y square. Let's collect like terms now. By collecting like terms, I'm going to have here as y square is equals to 4ax. So now, when you have a parabola facing the positive x-axis, when you have a parabola facing the positive axis, it is of the form y squared is equals to 4ax. So that is exactly what this particular one is dealing with. So now, what happens to a line that passes through? What happens to a line that passes through the focus and touches these 2 points, that touches 2 end points? That particular line is a line segment. Actually, is a line segment that is passing through this particular focus, and if you look at the same line, it's actually perpendicular. If you look at it, it's also perpendicular to the axis of symmetry. That particular line now is what we refer to as the latus rectum. Yes, in latus rectum we have it as a comma 2a, as the case may be. So I can have this space as L prime, I can call this space as my what? As my L. So this L, so we are saying that our L, F, L prime is what we refer to as the latus rectum. So now, like I said earlier, that I want to also show the other forms of this particular parabola. The other forms of this particular parabola, which is, I have just shown you y squared is equals to 4ax. So now let me show you the other form, which is y squared is equals to minus 4ax. So to what direction is the parabola going to be facing? Now let's follow me to this other part of the board where I will be showing you exactly this part. Now we have it being said this way. In that case, we have, so we want to consider quickly, let's consider the parabola y squared to be equals to minus 4ax. Let's consider that quickly. Now, if you consider that, we are going to have this in this manner. We have it this way. We have the curve passing through the origin. This time, passing through the origin, and this particular origin here, this is vertex, which is the 0, 0. Now, with this 0, 0, what do we observe here? We are saying that we are going to place the focus here. Let's place the focus here. So that focus is, don't forget that this one now is a positive y, this is my negative x. So I'm going to have here as my f at this point here, which is my reference point for this focus. I'm having here as minus a, comma 0. Y is 0 on this line. So now if I have this point as minus a, comma 0, what else am I going to be having here? Let me have the directrix line away. It's not touching. Remember what we said for the parabola. The what now? The distance from the focus is equals to the distance from the directrix. So in that case, we are having this space now as, let's label this space as x equals to a. So if we have here as a comma, so at this point, let's have here as a. So I'm going to place this point here. Let's label this point as point M. So this point M indicates a comma 0. A comma 0. And I have this point here as p of x comma y. So joining this line down, remember what I said, the distance here, this is the distance of the directrix, we say is equals to the distance from the focus. So if I'm to solve this one out quickly, this point is a comma y. A comma y, that's a value. This value, that's a value here. So this is a comma y. So with this, we are saying that our pm all square is equals to pf all square. Don't forget that this curve now is facing the negative axis. Axis of symmetry is facing it like this, so it's facing the negative part of this. So at this point, we are saying that our pm square is equals to pf square. So we are having your x minus a all square, that is x minus a all square, equals to y minus y. Y minus y is 0, so we don't need to put it there. Then pf, that is x minus a, that will give you x plus a all square plus y minus 0. We have y minus 0 all square. With what we have here, it simply means that if I expand this, I should be having x squared minus 2ax plus a square is equals to, expanding this will give me x squared plus 2ax plus a square plus y square. With what I have here now, removing this, cancelling this out, I will also have x squared to be cancelled. By taking this, that is 0, this will be cancelled. So what are we going to end up having? We're going to have here as, taking this to the other side, we're going to have here as minus 2ax, minus 2ax, I'm having minus 2x minus 2ax is equals to y squared. And minus 2x is going to give me minus 4ax is equals to y squared. So rewriting this will be y squared is equals to minus 4ax. Now, with what I've just stated out here, it means that if the equation of the parabola is of this format, you cannot be using y squared is equals to 4ax. If you use this, you are not going to have your answers correctly, because your focus point now should not be, your focus will be negative, not positive. So you should know that 2 and minus 2, they are not the same. So you having a focus as 2 is not the same thing as having a focus as minus 2. So definitely you are going to miss that question out. And you cannot have your directrix too. So if your directrix now is supposed to be 2 and you are now having minus 2, definitely you have not obtained the right answer to that question. So now let's look at other forms, which is the x squared, which is equals to 4ay. Let's also look at the form of x squared equals to minus 4ay. In that regards to, we're going to be having it being drawn this way. Look at it now. I'll be solving it. I'll be showing that here. If you are to show this, we are not saying that if it is, we have to consider, let's consider the parabola, x squared to be equals to 4ay. Consider the parabola x squared is equals to 4ay. But for us to differentiate this particular one, let's try as much as possible to change this so that we can easily you can also actually use it, but let's just use b instead of what? Of a, 4by, so that we can easily differentiate it there. So now in this case now, this is going to be the parabola. I'm going to have it, though the vertex will still be at the origin. So but in this case now, I want it to be facing up. So I will join it more like as what? As minimum. So in this minimum, I have this point, this is my point V. Don't forget that this is still 0, 0. So I'll place my focus point at this place. So my focus point, which is now your F. So F here will be showing, F will be 0, B. F is 0, B. That's the focus point here. Now, I want to have a point outside, which is now the directrix. I remember I said the directrix does not touch the parabola itself. So now if I label that point, I'm going to place it this point. Now let's have this, the coordinate of that one here. I'm going to have it here. So at this point, we observe that our x here is negative. So we are saying that we have this place as minus b, comma, okay, minus b. No, this will be showing, okay, we have here as my p of x, comma, y. So instead of us having it, so here is showing x, here is showing x, here is showing x, comma b. This is showing x, comma, minus b. That is what is showing. Here is showing x, comma, minus b. So if you have to find this now, remember that we are trying as much as possible to do this. So I will label this point as my point N. So to find this now, I am saying that the distance of PF, which is the focus line, is equals to the distance of the directrix. So I will show this here quickly. So I'm also going to do that quickly, that my PM here, okay, I would like to work at this point here. Let me show this here. Let me show this here. So I'll be having it being spread out as my PM all square is equals to PF all square. my pm all square is equals to pf all square. So we are having this point as my x minus x. So x minus x, which is 0, which is, I don't need to write this any longer. So I'm going to have here as y minus b, which is y plus b all square. That is minus minus is plus. Then equals to pf. Pf is saying x minus 0 all square plus y minus b all square. If I expand this, I'm going to have y square plus 2by minus plus 2by plus b square to be equals to x square plus y square minus 2by plus b square. Y square cancels y square, b square cancels b square. So I'm going to have here as, taking this here onto the other side, I'm going to have here as 2by plus 2by is equals to x square. So my x square now is equals to 4by. So I have been able to show that my x square is equals to 4by. So when you see a question, whereby you see a question, you have to understand the format by which this question is being asked. You cannot just answer questions that have to do with the x square. Probably it is facing the parabola itself is facing the positive y-axis. You are now comparing it with y squared, which is equals to 4ax, that is actually facing the positive x-axis. If you do that, your answers are going to be wrong. Now let's consider the last one. The last one, which is saying that x squared is equals to minus 4by. So in this case now, this particular curve will no longer be a minimum case passing through the vertex, but now it will be showing a maximum curve which is also passing through the vertex. So we are going to consider that here quickly. So in this case, we want to consider a case of x squared is equals to minus 4by. That's the case we want to quickly consider. So I'm going to draw the curve out this way. So I'm going to have a curve showing this, and at this point now I have a focus here. I have my f, which is showing okay, this is showing 0 because x is 0 here, comma minus b. That's what it's showing here. X is showing this. So I will have my line of directrix here. That line of directrix here, I'm going to tag this point here. I'm going to have it this way. At this point now, I'm going to have this point. Let's call that point N, which is going to be, that will be point which is x, comma what, comma b. We're going to have it as x, comma b. So we have this space which is my p of, this is my p of x, comma y. This is my p of x, comma y. So remember what I said, that the line from the focus, the distance from the focus is equals to the distance from the directrix. So to solve that question out is similar to what we've just done. So we are going to have it in this particular format. So we are saying that our pm square is equals to pf all square. Our pm square is equals to pf all square. So what's my pm all square? So we are having it as, this will give you x minus x is 0. So I'm going to have here as y minus b all square is equals to pf square. And what's my pf square now? We're going to have it as x minus 0 all square plus y minus minus b, that is y plus b all square. By expanding this, if I expand this, I'm going to have y square minus 2by plus b square is equals to x square plus y square plus 2by plus b square plus b square. So with what we have here, we are saying that this will cancel this. My big square will cancel this. Taking this to the other side, we are going to have minus 2by minus 2by is equals to x square. So at this point we are going to have our x squared to be equals to, we are going to have x squared to be equals to minus 4by, and this is the equation to finding the parabola which is actually fixing the negative y axis. You can see it here that is facing down. So when a question comes and you discover that they are giving you to find, they gave you a question that x squared is equals to minus 4a, so maybe it's showing, they just gave you a question like x squared is equals to minus 4y. You should know that this question, in as much is showing negative, if you have to sketch it, you cannot sketch this kind of question and you are not placing it like this. You are placing like this. It's totally wrong. Doing this is totally wrong. This is not, in this case, this one only shows y squared. This is showing y squared is equals to minus 4x. That's what it's showing. So always understand where to sketch. So if you are sketching it, know where you are placing it. You cannot just sketch anyhow. From the focus, if I have any focus, I can easily know where the point is being placed, because that focus is placed where? Is placed on the axis of symmetry. This is my own axis of symmetry. If I have a situation whereby I have a focus that is showing probably showing 2,0 as the case may be, definitely I know that this is on the what now? On the x axis, because it is saying that my x here is 2. That is what it means. So in the same way, if I now have it the other way around, if I have it as 0,2, definitely I know that this is, to sketch this now simply involves that it is what now? It is on the y axis, because my x here is 0 and my y is what now? My y is 2. So if I'm to do that, that means it should be something like this. That is what it means, that the focus is located around this point. Remember that I said this line here is the axis of symmetry here, and I have this one again, another axis of symmetry. This is the axis of symmetry this is the one for x, and this is the one for what? For y. So all of this explains this particular concept of parabola. So now, like I said earlier, what can they ask you to do in a question? A question can be asked, they may be asking you to find the focus. A question can be asking you to find the directrix. A question can be asking you to find the vertex. Fine, like I said, the vertex may not always be. They are not always at the what? At the origin. But in this context of what we are trying to show, we are proving them to be at the what? At the origin. So in some question that comes in a canonical form, they can ask you to leave a question in its canonical form. In that canonical form, what are you supposed to do? You are supposed to solve, because those kind of questions are not being placed on the what? These questions are not being placed at the origin. So we can have a question in that format that probably is being placed like this, and that canonical form is talking in respect of y in respect of x. You should write just that formula of y in respect to x. That is what it's asking you to do. So I'm still going to show you how to resolve such questions when you are being asked in this particular video.